Okay, so this problem is again from the medium bucket. It is about like boats to save people. So what it says is there will be some few people, and they will have to be carried from one side of the river, or whatever it is, to other side, and then each person actually uh, has a weight, and that is given as an array, and that is given as an array of integers. And a boat can carry maximum of 2 people, and it has a maximum capacity limit. So maximum it can carry 2 people. So we need to find how many minimum number of boats are required to carry all the people. And also it says it is guaranteed each person can be carried by a boat. So it means like if the limit is something about like 20 pounds, so all the weights won't in what you say, all the weights will be less than or equal to 20 pounds. And just to see some of the examples here. So the first one is like this. So this is a people array which are having weights. The first person has a weight of 1, I don't know, maybe 1 pound. Okay, and the second has 2 pounds, and the limit is 3. So these guys will only need one board because they both can fit into a single board. If we add the weights 1 plus 2, it is 3. So they are equal to the limit, so that is fine. So they can just go by one board. And if we have another example here, so here actually, so you have 4 people, one is of 3, and 2 of them are having 2 weights, and the other one is having 1. So here you can have 3 people. So it will be like a combination of 1 and 2, the weights of 1 and 2 people, and the second will be just like a 2, and the third will be carrying only the third person whose weight is 3. And another example is similar to that. If you have some array like this, 3, 5, 3, 4, and the limit is 5, you'll need 4 boards actually. So whenever there is a limit 5, so only one person can be carried, so that is one person. And if you see like 3 and 3, if we add, because they are the least ones, if we add both of them, it will be 6, and it will be more than the limit, so they can't go in one board. So 3 will have to go also in separate boards, and similar case for 4, and therefore we need 4 boards over here. And also the problem statement says that the length of this array can be maximum 50,000, and the limit maximum will be 30,000. So the maximum weight will be something like a 30,000, and you can have about 50,000 such elements in an array, or 50,000 people to be carried. So we'll have to find the minimum number of boards required to carry all the persons. So any questions about the problem statement? Okay, so
people like don't need to go in the order in that array. We can pick any 2 random, like maybe 2 or 3 random people, whatever is needed.
Yeah, so it's not a contiguous here. You can pick them in any order. That is right. So you don't have to stick to the order.
Okay.
Yeah, so the way I think is like, the first solution would be like do a simple sort first. Okay, so if I have an array, something like the second example, 3, 2, 2, 1, and the limit here is 3, I would just sort the array first. like 1, 2, 2, and then 3. And then start 2 pointers, one starting at the left and one starting at the right. And then I'll add both the values, like now in this case, so okay, let me increase the font size now. Okay, well, I'll just share my okay. So if this is the one, so if I sort it, it will be something like 1, 2, 2, and then 3, right? So I can start with left pointer here and then the right pointer here. And then if I add both the values, it will be 1 plus 3, and the limit is, so the limit is 3. So 1 plus 3, if it is less than or equal to limit, so this is not less than or equal to the limit. So what it means that only one person of the highest weight will go through in one board. So in that case, I just need to decrement. Okay, so I need to add 1 if I have if I set a boards variable to 0. So I'll say that okay, so I will take one board for one person on the right side, and I'll just move this right person. Okay, I'll decrement the right pointer. So again, I'll compare 1 plus 2 if it is lesser than the limit, lesser than or equal to limit. So they are lesser than or equal to limit. So they both can go in a single board. So then I will just increment the board counter here, and then I decrement the R as well as increment the L. And so here, when both are on the same, the left and right pointer, or on the same element, it means they need a single, there's only single person. So he will need a special board. So it will be another 3. So using sorting and then using a 2-pointer approach, this can be solved, but only the time complexity will be of O n log n. So that will be the time complexity. Okay, so is this solution clear, or you have any questions on that?
Hey, Santosh, how is it n log n? It's a log n, right?
No, I'm sorting, right? When I'm sorting,
Oh, okay.
so therefore it is n log n.
Okay, got it. Okay.
Yeah, so just, okay, the implementation is slightly.
Yeah, one more thing. Can we, I mean, put a left and right pointer on the, on the 0 itself, and just keep filling myself until and unless, I'm exhausted. Like here, for 1, 2, 2, 3, I will simply like start summing 1 plus 2, 3, right? Hello.
Yeah, sorry. Yeah, go ahead.
Yeah. For this example itself, 1, 2, 2, 3.
Okay.
I will sum up 1 plus 2. No, you can keep the right pointer there itself in the where L is right.
Oh, you mean to say at the
only,
beginning?
yeah,
Both of the beginning? Mm-hmm.
yes. So it's like only one loop, one variable. So L and R are not required actually.
Mm-hmm.
So 1 plus 2, that will be 3, right? So here that means these two I can put up in one bucket, like one board, and for these, for for next two, and after if I add 3 in that, I cannot do it. So these two has to be separated, right? So that would be like 3, right?
Yeah, but in that case, now this array is like that, right? So yeah, that might also work. But if we have something like 1, 1, 1, 1, 1, 1, okay, and 1, 1, so you have 2, something like 2, sorry, 2, 2, and any things, long array, a bigger array, and then you have some limit about, say, 9. So it might be sometimes if you have a higher ones over here, it is always better to check with the lower one. So they both can go together, right? So you have more number of 8s here. So it is always better to fill the maximum capacity of the board first and then look for the smaller ones. Is that slightly clear or?
Can you explain again why it not work?
No, I'm not saying it might not work, but the thing is, first, actually, you have to look for filling the complete capacity of the boards, right?
So I think
so
we
here
need
you,
to be greedy here.
yeah. So here, if you are actually filling the just one year, and then at the end, you will have to give for the 8, even if the capacity is 9, so still you will have to give them separate board over here, right?
Yes.
So instead of that, you can actually have 8 and 1 together to go on a single board. Okay, and then so you're reducing the number of boards.
Yeah, basically what Santosh is trying to say is like he's going in the greedy approach where he is finding the largest value and trying to decrease it from there. That's why he sorted out in the...
Yes, but at the end, we still need to go to every single value.
Yeah, that's true. But if you do it this way, you know, if you try to fill the complete capacity first and then go for that. Sorry, go ahead.
So 1, 2, 2, 3, and make your limit equal to 4 and see how it works. I have to drop also, so I hope that will be a counterexample.
Oh, you mean to say for this one, right? Okay, 4, right? Okay, so in this case, you know, so, okay, first let me do with my approach. If I say 1, 3, okay, so this will be one board. And then you in the second one will be 2 boards, right? So, but if we go both left and right, so this will be 1 and 2, right? One board. And then the second one, actually, you cannot fill 2 and 3 both in the same board, right? So you'll have to have a separate board for 2 and separate board for 3. So here you will need 3 boards. And in this case, the above case, you'll need 2 boards. Okay, so that is the reason actually, yeah. So that is the reason we go this way. Okay, but this n log n is also slightly on the higher side. That is what they say. But okay, let us quickly run through the solution first. Are you able to see the Leetcode screen now?
No.
Okay, just wait. Let me share. Okay. So is it visible?
Yeah.
Okay. So this solution actually is, you know, just do a sort over here. Okay. And then I'm setting this left and right pointer over here.
Okay.
And it's very simple implementation. As we just discussed, you have this left and right. Okay, just to be very clear, I'm just showing all these things, but it can be done. It can be optimized. The code can be optimized much better. So I'm just showing 3 conditions. If you go for this first condition, what we were discussing, if it is less than or equal to limit, you increment and decrement the right and left pointer, and then increment the board name and numbers. Or else if it is greater than the limit, you just have to decrement the right counter and increment the board. But if the both of them are on the same pointer, they just increment the number of boards and then return the boards. Okay, so but this solution is O of n. Okay, so my question is it possible to do this solution without in O of n with using some extra space? Any thoughts on that? So if you want to be more efficient on the timing, we are allowed to, you know, it's not written in the problem statement, but we can do this solution in O of n, but without, with some, adding some more space to this. With space of O of n and time complexity of O of n, that also can be achieved. So I will just explain you the way I thought about it. So the way, okay, if we take this example again, okay, instead of, okay, this one. Okay, instead of sorting, we can do it this way. We don't need to sort. First, what we can do is we can set a weight, some array, which will be equal to size of limit plus 1. And here, first we initialize all the values, like limit is 3, so we'll have 4 elements here, initialize to 0. And now what we do is we go through this array and iterate through it. And whenever we see any element, like here it is a 3 first, so we just increment the value of 3 here, so 1. And we have the number 2 twice, so we just increment the 2 here twice. And then we have 1 here, just increment the value 1. And then we have we set 2 pointers, because the 0 index doesn't matter here. We just set the left pointer to here and then the right pointer to here. Oh, sorry. Left pointer to the first index, and then if we set the right pointer to this index, so we do again the 2 pointer approach, but here in this case the indexes itself are the weights, and this array actually is the frequency, or maybe the number of peoples in each weight category. So
it seems like you're doing like a count sort or bucket sort.
Yeah, sort of bucket sort, yeah, but not exactly sort, but yeah, just putting them in these buckets. And then here again you see, you always compare, like if L plus R is less than or equal to limit. So there are actually 3 conditions to be looked for. One is first, if the, or maybe whatever is the lesser in these two, just what do you say, you actually, you have a both value which you have to return, which is equal to 0. So in this, the value of L and the value of R, just look for which is minimum. Here both are same, so we can always say that increment 1, okay, the both size, and then you make this as a 0 because you've already consumed these 2 people, and then decrement both these ones, sorry, move this pointer R to this place and then this one to L. So now here in this case we have 2, and the index is also 2, but if you say 2 times 2 will be 4, so it is going to cross the limit. So in that case we know that it needs 3 boards here, sorry, 2 boards here. So we have to divide this number by 2 and also mod this number. If it is, if it was 3 over here, then we'll have to actually add, okay, first if it's 2, just add 2 here, so it becomes 3. And in case if there was an example where it was 3, so you'll have to add, actually it will be 0, 1, and then it would have been 4. So this is only a special case. So 1 will be actually to look for the limits, and in this you'll have to look for the first condition, if L is less than R, okay, or second will be the opposite way, like L is greater than R, and the third would be if they both are equal, L is equal to R, okay. And this condition, actually when the L and both of them are at the same position, then the condition will be slightly different. Okay, so I think that if it's not more clear, I can just show you another example here. So if we have a big array like this, okay, and then we have so many people over here, and then okay, so I'm actually creating this frequency array over here. If you see, like 8 is twice, it is here, and then 7 is again twice, it is over here. So 1 is only 1. So we have some places where there are no people, so they are all zeros, right? So in this case, I start with L and R first. Okay, so if I actually go by, okay, so the first thing is if L plus R is less than or equal to limit. Okay, in this condition, L's value is 1 and R value is 8. So if I add 1 plus 8, which is 9, so it is not in this range, right? It is bigger than this range. So for this, what we have to do, we just have to do the same way what we did earlier. We just have to move this right pointer. But before moving the right pointer, whatever the values are in this location of the R pointer, we just have to add to the board. So there are 2, right? So I just add 2 over here. Okay, and then I can make this as a 0 and just shift my R. Okay, here now I compare with L with R. Okay, when I'm comparing L with R, now I see that if 1 plus 7 is 8, it is less than the limit. Sorry, it is equal to the limit. So now I can compare whether, actually I have to compare if the value of L is lesser than the value of R. So the value of L is lesser than the value of R. So what I do is I take this value 1 and subtract from R. Okay, so here 1 is left, and actually I make this as 0. Okay, and also now it is the minimum value was 1, so I added that over here. So we need actually 1 board to go ahead, right? So I make this as a 3, and then I keep on shifting the L till if there are no zeros over here, until I reach some value. Okay, so now when I come to L and I compare with R, so I see again now that this time L's value is greater than the R value. Okay, so in that case what I have to do is I have to take this R value here, okay, subtract this R value from L. So this becomes 2 and this R value becomes 0, and I actually add that to this boards over here. So this becomes 3 plus 1 will be 4. And then I shift this R pointer till I don't encounter, so till I encounter any positive non-zero number. Now in this case, both of them are 2. So what I can do is I actually can add this 2 over here. So 4 plus 2 will be 6. And here I actually make this 0 over here and then make this 0 and shift both of them in this case. Okay, so I come to the place where actually both of them, now this is another special case where actually L is and R at the same position. So if L is equal to R position, so what for here actually I need to do is multiply L by 2, and then compare if it is less than or equal to limit. Okay, so if I do that, it means actually whatever the people are, actually the capacity of the boat is 2, right? So actually if I do multiply, if it is less than or equal to 2, then I can divide these numbers and then take that number of boats. Okay, but only I have to handle the odd and even condition over here. Or else if it is greater than the limit, then it means that each person requires a separate boat. Okay, in this case it is 4. So 4 multiplied by 2 is 8. So it is within the limits. So I can divide these 2 by 2. So I need a single boat over here, and therefore the answer becomes 7. Okay, so and then I again increment my pointers. So it is for the exit condition, and then I exit. So is this clear or?
Yep, it is clear. It's like a great solution. Thanks for explaining this.
Okay. So I just thought I could share this, but yeah. Okay, there are some chats. Okay. Yeah, so yeah, if it looks, the implementation way is also very simple, but it is slightly more things to take care of. Here, if I look at the left and right, if they are less than or equal to limit, then I have to follow these three conditions over here. But this can be written slightly more efficient way also, but for just understanding purpose, I've made it separate. Left is less than right, left is greater than right. And then if they are both are the same, and here if it is greater the limit, it is greater than the limit, just we have to add the number of votes. And if they are equal at the end, we just have to take care of the even and odd length and just add the votes if it's greater than the limit. Yeah. Okay.